In this lecture, you will learn a workflow to conduct any simulation in COMSOL multiphysics. So let's start the lecture. So this is the workflow in COMSOL multiphysics. The first step in this workflow is creating the geometry. Either you are working with one-dimensional, two-dimensional, or three-dimensional domains. So the first step is to create the geometry in COMSOL multiphysics. The second step in this workflow is material assignment. So after creating the domain or the geometry that you want to work with, you need to assign the appropriate material. For example, if you are working with a fluid flow problem, after designing the pipe or any fluid geometry, you need to assign the appropriate material. For example, if you are working with air or water or oil or any kind of fluid. So the second step in this workflow is the material assignment. After that, the third step is the physics. So in the third step of this workflow, you select the appropriate physics for your simulation model. After selecting the appropriate physics, the fourth step in this workflow is applying the boundary conditions and initial conditions to your domain. After applying the boundary and initial conditions, the fifth step in this workflow is creating the mesh. So creating the mesh involves dividing the domain into small elements. After that, the sixth step is selection of appropriate study and providing the right solver configuration. The seventh step in this workflow is the post-processing, where after the solution, you plot 2D or 3D results or graphs, and also you can generate animations in COMSOL multiphysics. So this is the 7-step workflow that you have to follow in COMSOL multiphysics to conduct any sort of simulation. So now we will go to each section of this workflow and try to learn that how we can implement that in COMSOL multiphysics. So the first step in this workflow is geometry creation. So in COMSOL multiphysics, you have the option to select the space dimension. So there are 6 types of different space dimensions that are available in COMSOL multiphysics, starting with the 3-dimensional domain or 2-dimensional axis symmetry, 2-dimensional, 1D axis symmetry, 1D and 0D. So based on your problem, you select the appropriate space dimension. So for example, if you're working with a 3-dimensional heat transfer system and you are designing a heat sink, then you need to select 3D. And if you're working with a 2-dimensional system, you need to select 2D. And if you're working with the symmetrical objects, then you need to select 2D axis symmetry or 1D axis symmetry based on your space dimension. The next image shows here that how the geometry section looks in COMSOL multiphysics. So under this geometry ribbon, you can find different sections that you can use to make a geometry. For example, if you are working with 2-dimensional, you will find different primitives, for example, circles, ellipse, rectangle, square, polygon. And these primitives you will learn in the second phase of this course. After that, you have some operations like Boolean operations and partition operations, and then you have transform function, and then you have conversion functions and other operations. So this is how a geometry option looks like in COMSOL multiphysics. Also, you have the sketch mode option in COMSOL multiphysics. If you select on sketch, you will get this window where you can work with polygon, circular arc, and you can use different quadratic, cubic, or interpolation curves. So this is how you use the sketch mode in COMSOL multiphysics. And if you selected 3D space dimension, then you will get these sort of options under the geometry ribbon, where you can use 3D primitives to create block, cone, cylinder, sphere, torus, or different objects. Also, you can use this work plane to make your own geometries using extrude, revolve, sweep, or other commands. So this is how a geometry creation section looks like in COMSOL multiphysics. You will learn more about it in the second phase of this course. And also, we will cover how to create 2-dimensional geometries and 3-dimensional geometries in COMSOL multiphysics in the phase number 2 of this course. After the first step of geometry creation in COMSOL multiphysics, the next step in the workflow is the material assignment. So you will find this material option in COMSOL. Under this ribbon, you can see different sections, for example, material section, property group, and user-defined libraries. So here you can see that the first option under the material is the add material. If you click on this add material, a new tab will appear where you can find different type of materials that are already built in COMSOL multiphysics. One of the option is built-in materials in COMSOL. If you open this built-in materials, you can find different materials. For example, you can see these are the commonly used materials in the real world. So you can select any material from COMSOL library and use it for your model. Also, if you want to define your own material, you can select this blank material option and the blank material will appear. Here you can use different properties for your material and assign the properties to run your simulation. Also, another option is user-defined libraries, where you can create your own material and add this to the existing library, or you can create your own library as well. So after the second step of material assignment in the workflow, the third step is the physics interface in COMSOL. So in COMSOL, under the physics ribbon, you can find different sections for the physics. For example, the first one is physics, and after that you have domain, boundary, and points. I will come to these later. So the first option is physics. So in the physics section, if you click on this add physics, another window will appear with the name of add physics. So you can select any physics that you want to work with by just opening the physics modules. So for example, if you want to work with laminar flow physics, then you need to open this fluid flow. If you open this fluid flow, you will get different options. For example, single phase flow, multi-phase flow, porous media, non-isothermal, and other options. And to select the laminar flow, again, if you click on this single phase flow, you will find this option of laminar flow. This is one way of selecting the physics in COMSOL. The other way is that you can write the physics that you're looking for in this search bar and search. Once you click on search, the physics will appear, then you can select the physics that you want to work with. After that, if you want to add more physics, you can go to the add physics again and select other physics as well to solve the multi-physics problem. So to add the multi-physics coupling, the next option is add multi-physics, where you can add the multi-physics coupling for your problem. After the third step of adding physics in COMSOL multi-physics workflow, the next step, which is step number 4, is the constraints in COMSOL. So this is where you select the boundary conditions and initial conditions for your problem. So for example, under the physics ribbon, under this domain, if you select this domain, you have the option to select the initial values, where you can provide the initial boundary conditions to the problem. To apply the boundary conditions, you need to click on this boundary and then select the boundaries. Once you click on boundaries, you will find this tab, which shows the different boundary conditions that are available for this certain physics. So if you are working with a different physics, you will find different boundary condition options here. So this case is for laminar flow, so you can find the inlet flow condition, outlet condition, wall condition, symmetry, open boundary, and other boundary conditions. So you can select the appropriate boundary condition and apply to your model to solve the simulation smoothly. After the step number 4 of applying boundary conditions, the next step in the workflow is meshing. So this is very critical step in COMSOL modeling workflow. This defines your simulation going to be converged or no. So you need to be very careful while working with the mesh. So COMSOL provides a full control over generating the mesh. So under the mesh ribbon, you will find this mesh section. In this mesh section, you can click on add mesh and add any sort of mesh. So there are mainly two types of mesh system in COMSOL. One is physics control, the other one is user control. We will discuss these options in detail in the upcoming phases of this course. So after adding the mesh, you can just simply click on build mesh and then your mesh will be created. And you have different options for the mesh. So you can select the element types in the generator section, where you can find free triangular element, free quad, map, edge, and different other operations. So here you can see some of the examples. The first one is the generation of mesh in the heatsink. The second one is 2D car, and the third one is the three-dimensional golf ball. So you will learn how to generate an efficient mesh in COMSOL multiphysics in upcoming phases. After the meshing, the next step is the study and solver configuration. In COMSOL multiphysics, you can select the study under the study ribbon, and under the study section, you can select the add study. After selecting add study, you will be given the option to select the available studies for the selected physics. For example, for the laminar flow, we can conduct either stationary study or time dependent. So based on your physics, you will find different options here. So once you click on the studies tab, your studies tab will be added to the model builder. After that, if you want to see the solver configuration, then you can simply click on this show default solver. Then it will show you the default configuration for the selected study, and you can control different parameters in the study. For example, so you can control either you want to run a fully coupled simulation or a segregated simulation, or also you can select different type of solvers available in COMSOL, for example, MUMS, Pardiso, and other solvers. Also, you have option to apply the parametric sweep, which you will learn in the phase 6 of this course. And also you can apply the material sweep as well. And also you can select this optimization option to apply the optimization to your system. So after selecting the appropriate study and solver configuration, the next and the final step in COMSOL modeling workflow is the post-processing in COMSOL. In post-processing, under the results ribbon, you have different sections. For example, you have plots, definitions, data sets, numerical, exports, report, presentation, and clear. So you can find different options. So under these options, you can plot 2D plots, 3D plots, or 1D plots. For example, this is the example of the 1D plot where we have created the graph, and this is an example of 2D plot, and the final one, this is the heat sink temperature. This is an example of 3D plot. So you can plot 2D, 3D, or 1D plots using these options. So now let's summarize that what we have discussed so far. So this is the summary for the simulation workflow in COMSOL multiphysics. The first step is the creation of 2D geometry. Then the second step is the material assignment. After that, you define the physics. After that, you apply the boundary condition. In step number 5, you discretize or divide your domain into small elements. And then in the step 6, you select the appropriate study and also provide the appropriate solver configurations. And finally, you perform the post processing, either plotting 2D, 3D results, or creating graph or generating animations. So this is a very typical workflow in COMSOL multiphysics that you use to develop any simulation model in COMSOL multiphysics. So now you have learned the workflow of any simulation in COMSOL. So now let's move to COMSOL software and apply all these 7 steps and see how a simulation works in a bigger picture.